I typed ahead of time for you so you can think through them. But conditional probability is this kind of information where you get numbers of information or numbers that would help you determine different probabilities. And you're looking at a bunch of information and you're supposed to determine different probabilities. So you're looking at numbers. I want you to tell me the probability according to this, what appears to be a middle school, I would assume, 6th, 7th, 8th grade. I don't know if these are numbers of students at the school or if these are numbers of students who won something. It doesn't really matter. But according to this table with this information, what is the probability if I choose one of these students at random that I choose a boy? So I would write that down as the probability of selecting a boy. If I just say boy, then I'm saying what is the probability of you being a boy on this table? How would I find that?
You add those boys and
Figure out how many boys there are. Yep.
divide by 3.
We're supposed to divide by the total, remember. Successes would be boy. Dividing by the total number of people that I could choose from.
The total one.
The total what?
Of boys.
Boys.
There are boys, 116 of them, divided by the total number of people. Since it's supposed to be successes out of total. What is it?
235.
Okay. And then we would just check to see if that reduces.
No.
So that is the probability of you being a boy. What about the probability of selecting a 6th grader?
80.
How'd you get 80?
I added 42 and 38.
Okay, so all the 6th graders divided by
235.
235. Does it reduce?
Yes, by 5.
Yeah, it will at least reduce by 5. So we'll
5.
check it and figure out what it is.
47 over 47 is the denominator. And
He's dividing everything by 5.
12.
It's not 12.
16.
Close.
Oh, 6. Oh, that's
No.
80 now.
Oh, yeah. Okay, so these are normal probabilities. Hopefully, you could have found these with a little bit of background knowledge of knowing you're supposed to add together to find totals before. When I say conditional probability, though, I give you conditions. For example, I might set up a problem that instead of asking for the boys or the 6th graders just in general, I get a little more specific and I say, what is the probability of me choosing a 6th grader given that I'm already selecting a boy? So this is different notation.
So a 6th
The
grade
big
boy.
tall line, yeah, is basically saying I'm putting you in a category. Rather than just looking for a 6th grader, I'm looking for a 6th grader assuming that I'm choosing a boy.
So would you put 40?
80.
Wait, it would be. So wait, you have to do the 80. And then you do something else with 42.
What would be 42 or 80?
So final answer, if you think about this, and we'll think about where it came from in a second, it is 42 out of 80 because the boy part at the end is me putting you in a category. I'm saying, what's the probability that you're in 6th grade if you are a boy? So she's only looking at these two numbers. No, sorry, it's not 42 out of 80. 6th grade, close. You're close, Danny.
Boys and then all.
6th grade, given that you're a boy. Yeah, given that you're in this category. So the second one's the category. So I'm saying probability I'm in 6th grade, assuming that I'm already only working out of the boys. Can somebody reduce that for me?
21 over 58.
Thanks.
Wait, so this guys don't. Never mind. It doesn't matter.
Okay. Let's flip it around and look at how it would change if I said boys, given that you're in 6th grade then. So think about the second thing as the category. I'm saying I want the probability you're a boy, assuming you are in 6th grade. So the 6th grade is the category I'm putting you in, your total. What's the probability of being a boy? That's the 42 out of, what'd you say? 80. So that's the other way around. You see the difference in where the denominators came from. Of course, I should reduce that. 21 out of 40 does, no, it doesn't go any further, I guess. Okay? So this is what I'm calling conditional probability. I'm giving you some sort of condition you have to meet before I actually find how many there are. Try for yourself thinking about the probability being that you're a girl given that you're in 7th grade, just to see if you can pick one out yourself. So don't yell this one out. I want the probability of being a girl, Sean, give it back. Girl, given that you are in 7th grade. Make a guess on your paper. Girl, given that you're in 7th. So your girls in 7th should be 35 out of the total of 69 that are in 7th grade. Did you get it? Cool. How about, this is a fun one they always like to throw at you, the probability of being a girl given that you're a boy. You see this one thrown in there a lot. Yeah. What's the probability of you being a girl, assuming that you're a boy?
100%.
It depends on what kind of
0.
surgery you
Good. I'll see that one thrown a lot on there, like what's the probability of a 6th grader given that they're a 7th grader? You can't be in more than one of those vertical or horizontal categories at the same time, I hope. So that means it's 0. So they're fun things to think through. You just need to make sure you're watching and paying attention to what they're asking you to find. So I want you to think about what you're finding here. On these last 4, when I had these conditional probabilities, given that you were in one category, that second thing tells you the category you're in. I want you to take a look at the problem of how to actually find these. For each of these last 3, I want you to note this to yourself. Whenever I give you 2 things that I want you to find, like A given B, the way that you got your answer was for the top number. If A is the first qualification and B is the second qualification, you looked for the number of people who fell in both categories. So for example, this boy 6th grade thing, when you gave me the number 42 on the top, that was the boys in 6th grade, the people who met both of those categories. Same thing, boy, 6th grade boy, 42. Over here, a girl, given that they're in 7th grade, you looked at the number who were in both. For the bottom, you looked at only which one? The which one? B? The right one. So when I went to get this 80, that was all the 6th graders. The 116, that was all the boys. The 7th graders were the 69.
So over 7th graders.
So yeah, you're over the second one. But on the top, what you're finding is how many of them are in both categories. We'd call that A and B. This right here is how you found all of those. So this is your key for doing conditional probability. You figure out how many are in both categories, and then you figure out how many are in the second category, and you divide. Now with a table, it's super easy to see them, but they're not all with tables. Sometimes you have to think about the sample space on your own. You can draw a table for yourself, or you can draw a picture of what your sample space will look like, and sometimes those things are going to be the things that help you figure out how many are in both and how many are in the second, since those are the 2 numbers you need to divide. So look at the second example I gave you. You're tossing 3 coins in the air. I want to know the probability that you're going to toss 2 heads, so 2 out of the 3, given that you toss at least 1 heads. So assuming you toss at least 1, I want you to only look at those. I want to know the probability that you actually toss 2.
Well, if you only toss
one, it would be 50.
2 heads, I should say. You're tossing 3 coins, though. So what does it
You
look
already
like?
got one
I'm gonna
head.
go with 50%.
50%?
Yeah, I agree.
Any other guesses?
Right, because you have
Ever.
each coin is 50%. If you're only tossing one at a time, it would be 50% every time.
You're tossing all 3.
At
Sorry.
one time.
Yeah, so you toss all 3 coins. I want to know the probability that when they landed, you got 2 heads out of the 3. Assuming, though, that you got at least 1 head. So think about tossing the coins. How many different ways are there for 3 coins to land?
6.
One or
No,
two.
Each coin has 2 options.
So it makes
So how many
There's
sequences
6
are there?
over.
There's 6 ways. 1 6.
More than 6.
So 16%.
No, less than 12. How do we figure out the number of ways to do it?
Times them all together.
Times them all together. How many ways for the first one? 2. How many ways for the next one?
4.
But you're not multiplying.
8. 17.
2 times 2 times 2. Yeah, there are 8 different possibilities. What are they? I could get heads, 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 right?
Tails, tails, tails.
I could get tails, tails, tails,
Heads, tails, heads.
heads, tails, tails, heads, tails, heads.
Tails, heads, tails.
Okay, tails, heads, tails. What else?
H,
Tails,
T,
tails,
H.
heads.
Tails, tails, heads. And what'd you say?
Heads, heads, tails.
I'm removing the TTT because it doesn't have an H.
Heads, tails, tails.
Oh, yeah, haven't done that one.
Tails, heads.
Did I do that one?
Wait,
Doesn't look like it.
HTT the same as the TH in this case?
Is that all of them?
So now you're going to remove TTT because it doesn't have an H in it.
So the first question is, I want the probability that I'm getting 2 heads. If we were to write this out in that notation, given that I had at least 1 heads. This is our problem. So these are our A and our B. So you just told me I'm supposed to find the probability of being A and B, and then I'm supposed to divide by the probability of B, and that will get me my overall probability. So I need to know the probability of being in both categories, and then the probability of being in just the second category, and I need to divide.
JB's done.
So I need the probability of A and B, and I'm going to need the probability of B, and I'm supposed to divide them. That's going to get me my answer. The easier one is typically the second one, because that doesn't have an and in it. Start with probability of B. What is the probability of me getting at least 1 heads? Out of these 8 scenarios, how many of them have at least 1 that is heads?
3.
7.
At least one.
At least 1. 7 out of 8. Okay. That is the probability of part B, at least 1 heads, which is what you told me I'm supposed to divide by. There are 7 out of 8.
2 heads.
But what about the probability of me getting 2 heads and at least 1 heads?
4. 1. Yeah, 1. 3.
1, 2, 3, 4, 5, 6, 7.
So 2 heads and at least 1 heads. Does this one have 2 heads and at least 1 heads?
No.
No.
No, it has 3. Does this one?
No.
Okay. Does this one?
Yeah.
Okay. So this one is one of them. Does this one?
Yes.
No.
What about this one?
No.
This one?
Yes.
Yes.
3.
Good.
Yes.
So there are 3 out of the 8 that had what we wanted. 2 heads and at least 1.
How do we do that in numbers?
How do you divide 2 fractions?
Decimal.
You change it into a decimal.
That would be one way, or you could keep, change, flip. Keep, flip, change, whatever you want to call it.
KFC.
KFC. That's what I do. I think about my first fraction, and then I multiply by the reciprocal of my second fraction. Final answer is?
3 over 7.
Beautiful. That
Actually, first.
is the answer. The hardest part, I think, is figuring out your sample space and figuring out which pieces of your sample space you're looking at.
Very dry.
Questions on that?
What you just did, though, did we?
What do you
Can we
mean?
just change it into a decimal?
If you change it into a decimal, eventually you want to change it back into a fraction because that's how we're being asked to represent our answers right now, but yes, you could. Okay? So it'd be good to practice it. It's faster. Yes, sir.
Why did you put 8 over 7?
8 over 7 right here.
KFC.
This is a division.
Yeah.
And so anytime we go to divide by 7 over 8, we multiply by the reciprocal, multiplying fraction.
And then, why would you say with 3/8?
Why would I what?
Why wouldn't you do the same?
The reciprocal?
No, with 3/8.
Like flip it over, you're asking?
Yeah.
We never flip over the first fraction. You only flip over the second one when you're doing fractions.
How do you get 3/7?
I reduced on the diagonal. All right, so next one, similar problem. Let's see if we can do it even more efficiently. Now that we know our plan of attack, I have families. They have 2 pets. So I take a survey of all these families that have 2 pets. They have either cats and or dogs. Okay, so some kind of combination. We find all the people who have in their family 2 pets made up of cats and dogs.
Mine's only dog.
I don't care because we're doing math right now.
I don't have this phone. I have a lot more.
What is the probability that if I look at all these families, I choose a random family who have exactly 2 cats,
The second pet is.
the second pet is a cat. So I go out and I ask these families, what does it look like in terms of our sample space? Can you tell me how many members are in there correctly? How many different options are there for families having these pets?
Cat, dog,
So they-
cat, dog.
So how many are there? 4. Good, you said, can you read them again, Alyssa?
Cat and cat.
Okay.
Dog and dog. Cat, dog. Dog,
Okay. Remember, if we didn't know how many there were supposed to be so that we could make sure we didn't miss any, you can multiply your options. There are 2 different pets and 2 different pets. So there are 4. So now I'm supposed to find the probability of 2 cats given that the second is a cat. So this is my A and this is my B. So you're supposed to figure out the probability of being in both and then the probability of being only in the second category.
category.
The second being a cat, that category, yes. Category, thank you. Natalie.
Or the one on the bottom.
For the bottom, all right, so Alyssa says all of her options where she has a second pet being a cat are these 2. 2 out of 4 goes on the bottom.
Can I put 1/2?
You could put 1/2, yes. If you reduce them at the beginning, it means that you're not going to have to reduce at the end, which is
And
smart.
then, so then 1/4 on the top.
On the top, yeah. Now, I'm asking for you to be in both categories, meaning you have to have 2 cats, and the second one needs to be a cat. Well, that's just this guy right here.
So 1 out of 4.
Yeah. So we go through and do the math. I have a 4 multiplied by my 4 over 2, or 2 over 1 if you had already reduced it. Final answer should reduce to half. Meaning there's a 50% chance that that family will be chosen.
So listen, I have sensed a pattern.
What's your pattern?
When after you flip it, the answer is like the first numerator. So it'd be the 2 numerators, the half numerator with the second numerator.
They do. They always reduce out. So
Yeah,
that
like when you're like instead of having to do all the steps, couldn't you take as soon as you get 1 over 4 and 2 over 4 would it be 1 over 2? Could you just
it's
do
true. Anytime you're doing fraction work, if these denominators are the same, they really can just drop out.
that? Okay.
That
So
is-
but if the denominator's the same.
Yes. Yeah, as long as the denominator's the same.
Checks out.
Take for every time.
Yeah. Questions on that? We only have 1 more.
And then we have to do bookwork.
So here,
Are there really guys that
when I was a kid, my brother played this Magic Gathering game, and he had a die.
But is it like kind of like
Then drive up through the internet.
Yeah,
how do you know what's on top?
well, they have numbers on them.
How does it
There's a flat piece.
I don't think.
Yeah, they do have flat pieces, so you can tell where the top is, but it is pretty busy looking. So we have all sorts of these. Our job.
Are you like laughing really weird or trying to get us to be quiet?
Hoping with a weird sound you'll actually listen. You have a 20-sided die. You have the integers 1 through 20 on the sides. Find the probability that you roll a number that's a multiple of 3 if you know that the number that you roll is going to be odd.
Which would be 3 times 3 times
3/20ths.
320, yeah.
They say 3/20.
I got 110.
110.
You're wrong.
5. So how would we set this up?
No, there's 6.
The nines trick with your It just helps.
The multiple of 3.
Good.
And then numbers odd.
Yep, perfect. So she's got our A and our B set up for us.
Now that one made more sense than the last two.
Good, I suppose. Yes, Nick?
Okay, how about this? There's 10 odds on a 20-sided die. How many of them are 3s?
How many of them are a multiple of 3?
That's the other way of doing it, though.
Yep.
Nick,
We got the bottom.
feeling so
You got the bottom?
Nick,
I got 320.
Okay. So they know that out of all the odds, or out of all the numbers, half of them are odds. How about the multiples of 3 and being odd?
There's 6.
3.
Oh, total is 6.
3 and 6. 1 half.
No, the top is 6. Like a round thinking.
You have to be a multiple of 3, 6, 9, 12, 15, 18. So these are your multiples of 3, but it has to be a multiple of 3 and odd.
So 320.
It's 3, 10.
So cross out the even.
Okay, I'll cross out the evens.
There you go.
So now I have 3 out of
6.
but out of all the odds though.
So 10.
Because it was, remember, 1, 3, 5, yeah, 7,
3 out of
9.
10.
I have to finish my list? Probably not, but these were all the odds, and I want to know how many of these numbers were in this list, essentially. So yeah, it'd be 3 out of the 10 of them. So now, I go through and I do my math. Denominators aren't the same, but we can still multiply by our reciprocal.
Oh wait, I just did that completely wrong.
Good. 3
No, I didn't.
Questions. They get tricky though, don't like you have to really stop and think about what you're doing when you don't have the sample space in front of you. I like the ones with the tables because the tables are a little bit simpler to pick out what you want. You could do them all this way, even the ones in the table, but it is usually easier if you can see the breakdown.
Which was like a fast way to do it.
This is the fast way to do it as far as I know. You got to think through your sample spaces.